So let's begin talking about how we actually do find those zeros. Before, we were given a number and we were to find if it was a zero. Well, how do we come up with those numbers? And so we use what's called the rational zeros theorem. And in the rational zeros theorem, that gives us a set of possible or potential rational zeros. And remember, a rational zero is a number that involves an integer or a fraction. So what we do is we look at our polynomial and we look at the constant to begin with. And we are going to make a list of all possible numbers that divide evenly into that constant. And those numbers we're going to label P. So I know that the numbers that multiply to be 6 are 1 and 6 and 2 and 3. I'm going to write each of those down. And I like to put them in order. And you have to write plus or minus in front of each of those numbers, because a positive or a negative of each of those numbers will divide into a -6. So that's our values for P. Then we look at our leading coefficient, which is the coefficient that comes first if your polynomial is written in descending powers of x. So in this case, Q is 2. And we write all the numbers that divide evenly into Q. The only two numbers that multiply to give 2 are 1 and 2. So Q equals plus or minus 1 and plus or minus 2. So that's your first step. Then your last step is you want to write all possible combinations of P over Q. So we're going to put 1 over 1, 2 over 1, 3 over 1, 6 over 1. Then we're going to put 1 over 2, 2 over 2, 3 over 2, and 6 over 2. So 1 over 1, 2 over 1, 3 over 1, and 6 over 1 are just 1, 2, 3, and 6. Plus or minus 6 is what that says. Now we'll do 2 over 1. Well, we already have, 1 over 2. Two over 2, which divides to equal a 1, so we don't need to write that down again. Then we'll do 3 over 2. And then 6 over 2 is 3, which is already in our list. So our list of potential rational zeros comes from that list of numbers. And there are 1, 2, 3, 4, 5, 6 positive and 6 negative. So there's a possible rational zeros come from this set of 12 numbers. Okay, let's try another one. And we're building on this concept, so we'll use this again in just a little bit. Let's find all the possible rational zeros for this one. Well, our P is -28, or 28 is the numbers that you want to use to find the factors of. So we know 1 times 28, hopefully I have enough room here. We know 2 times 14. And we know 4 times 7. So those are all of the numbers that divide evenly into 28, or -28. Now Q is the coefficient of the leading term, which in this case is a 1. So we can only use plus or minus 1 for our Q. Our potential rational zeros would be P over Q, which is 1 over 1, 2 over 1, 4 over 1, and so on. So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 7, plus or minus 14, and plus or minus 28. If we have rational x-intercepts, they will come from this list.